A pulse shift could change our world forever. The upcoming geomagnetic reversal is shocking, and we have virtually no enough way to protect ourselves against what it would do to the Earth. It is sure to come around, but nobody knows when. So, many questions yet about this millennium event. So, how will we know that the poles have changed? So, as humans, can we feel that? Can we, as individuals, take precautions? It's time for the pole shift. Between 772,000 and 774,000 years ago, it last reversed, because as ice caps melt, sea levels tend to rise, and vice versa. Earth's magnetic field geomagnetic reversal is not something we ought to be waiting for in the next million or thousand years. The jump is happening or has already started without us noticing. A special case of it is called a pole shift when the Earth's north and south poles switch places. The north-pointing compass would switch to south. The Earth's magnets turn, but it's like it's when they turn them around. Many thousands of times history has played this out, but never in the technologized age that we find ourselves in. The pole shift is most probably going to take a few decades. They can see this with constant shifts of the magnetic north and south poles. The actual jump would probably happen after some given degree of departure from the old positions, and then it would happen as fast as it could. But it's also possible that the north and south poles shift positions over periods of dozens or hundreds of years. We simply don't know exactly. Indeed, the natural question here is how scientists would know this thing was occurring in the first place. However, the answer to this exciting question also tells how the pole changes affect nature. Rocks and the seabed provide clues. Magma that rises from a volcano and turns to solid rock stores information about the Earth's magnetic field. At the time, scientists have found that the direction of magnetic field has changed when they looked at such rocks. Many places on the seabed there is also active magma. Hot material from inside the Earth continuously comes up on the seabed and changes the Earth's surface as it does so. Magma is also magnetized when it is solidified and the seafloor is marked with stripes that cross paths in both directions. The stripes are like a tape measure for the Earth's history, that the poles have turned several times. Did you know that the Earth's magnetic field sometimes collapses? One big unknown is in fact the question of what will the Earth's magnetic field do during that time. A few other things the Earth's magnetic field protects us from are solar radiation. Our entire electricity and communications network could be paralyzed by devastating solar storms that occur when a weakened geomagnetic field is combined with an observing geomagnetic field. According to researchers, the Earth's magnetic field will weaken considerably just before the actual jump, or perhaps will go totally out of order for a short time when the polarity reverses. This process could also be devastating for nature. They would also lose their sense of orientation. If marine mammals are stranded by the hundreds or thousands, and in the worst case die, it is because they are orienting themselves to the Earth's magnetic field. The Earth's magnetic field is also used by even bees. What of masses of unconscious and disoriented bees? So if there was a loss of work by these animals, there could be quite a big crop failure for us humans in terms of fruit and things like that. The Earth's magnetic field has already dropped during the last 3,000 years, warn the researchers. For decades, the European Center for Research and Teaching of Environmental Geosciences in Aix-en-Provence has been studying the pole shift effects and potential consequences. If the field continues to fall this rapidly, then we will soon pass into a critical phase. Specialized instruments, such as magnetometers, measure the strength and direction of this field and are then recorded by researchers. There are satellite missions, such as European Space Agency's SWARM mission, that supplements this data with statements across the globe. The field is continuously monitored and recorded for any long and short-term changes by several magnetic observatories around the world. We are very lucky with our magnetic field. It's true that out of all that we know about this thing we call the magnetic field, we only know so much about planet Earth's. So that's pretty great. This field has always been a special feature on our planet, and so we are lucky that someone thought to free this field, because otherwise, without it, the human race and all the wonderful wealth of life forms on this planet would probably not have existed. The interior of the planet is differently. It's more like that of our neighbor Mars, which has only very weak magnetic field. Because it has no protection, Mars has always been much more exposed to solar radiation than the Earth, which has basically lost its atmosphere and its water over millions of years. But if there was ever life on Mars, it died by desolation and desiccation. Because Venus has no magnetic field at all, making it impossible for that force to protect the atmosphere above it from total obliteration, perhaps we are now too far down the path of making Venus too hot and inhospitable a planet, and our Earth is too far down the road to prosperity and thriving. Without a magnetic field, we wouldn't exist, so. Of course, it is scary to know that it would collapse in a few years, even just briefly. Today, researchers estimate that at least 100 pole jumps have occurred in the last 20 million years, and some of the reversals took as long as 1,000 years. Is the already reported happening to the Earth's magnetic field the starting of such an era, or do we find ourselves in that jump once again? They don't know. This is why researchers have to pass. All we can do is look around and hope the repercussions won't be so onerous. The truth is, the Earth has been through all the jumps before, but at the time we don't actually know the precise effects the jumps had, whether there were climate changes, whether and how many species went extinct. The polar reversal requires weakening of the magnetic field to about 90% or to a threshold value. But if it takes thousands of years, then the Earth would perhaps be less protected for a long, long time. In fact, more high-energy particles from anywhere else in the universe would be hitting us. Commonly, these cosmic rays hit nitrogen and oxygen atoms in our atmosphere. Cosmogenic isotopes could form completely new examples of elements. Researchers directly link traces of carbon-14 and beryllium-10 in rock deposits to previous polarity reversals. It was the Earth's magnetic field that almost reversed 15 times since the last complete jump more than 700,000 years ago, but not completely. Such wobbles are called excursions by scientists. The most recent of these excursions only occurred 40,000 years ago. We may be seeing the signs of another excursion already, and the field strength is collapsing quite a bit, but not quite to its knees yet. What does the South Atlantic anomaly tell us? A large area of the Earth's magnetic field is also much weaker than at the poles. It is in the Atlantic Ocean, between South America and Africa. For short, this South Atlantic anomaly, SAA, is an odd characteristic of the Earth's crust in the Earth's magnetic core. We note corresponding changes in the flow of molten iron in the region SAA. Despite what always is happening to satellites above the SAA, suffering electronic failures, scientists can see above the SAA. We first discovered the SAA in the 1950s, which is when scientists saw its value to us drop by a further 6%. But it's also moving conspicuously to the west, and the South Atlantic anomaly is getting stronger. Scientists have no idea why it happens, and few can predict what will happen to it. Moreover, it's still not clear in which way this anomaly is linked to, or otherwise impacted, by the possibly imminent pole shift. In any event, similar disturbances already seen are worrying. Just imagine one day all satellites stop working. The internet would be gone, GPS, television would go, and other communication systems would fail as well. This could be an absolute catastrophe. Rapid movement of the magnetic North Pole. More of a mystery is facing researchers. One other thing going on in the Arctic is causing a stir. The magnetic North Pole has moved several times since records began in 1831 in an absolutely astonishing way. It now lies some 1,100 kilometers away from Canada, towards Siberia. The magnetic north is in perpetual motion, a point determined by the activity of the Earth's magnetic field. The geographic North Pole is a fixed point that is the northernmost point of the Earth's axis and thus marks the North Pole. The speed with which the North Pole is moving is striking, and not just because the distances are tremendous, but because the speed of the movement is increasing. The pole once moved at a speed of around 16 kilometers per year, but that rate is now growing to around 55 kilometers per year. The evidence of these processes deep inside the Earth lies in these changes. For likely sign of Earth's magnetic field fluctuations and changes, and thus changes and movements in the Earth's outer core. Perhaps these are the Earth's natural movements and are entirely harmless, but they may also presage something more involved, such as a geomagnetic reversal. For the moment, we know very little about what's really happening in our planet, and we have limited ability to study this. Seismic waves are what researchers usually listen deep in the Earth. Earthquake waves hitting the planet in different ways depend on what type of material they hit and whether their wavelength is long or short, and these reflections by differing layers and elements can tell scientists in exciting detail what is going on inside the Earth. Over the last few decades, we have been collecting this data and are now able to understand the physical conditions in the Earth's core fairly accurately due to state-of-the-art computer simulations. We know too little of its cycles and changes. These technologies have only been available to us for about 100 years. The day after the pole shift. For example, let's say that you were to get up the morning after the pole shift. Initially, you wouldn't even notice that anything's different. Strange lights in the sky that look like auras are something you might see. You check your cell, phone, and maybe the data on the current weather is wiped out as satellites down. Things may have collapsed entirely for the entire cell phone network. You may have to go without the GPS service if you use it at work. If you are a specialist looking after communications, air traffic, or navigation systems, you may well be in a bit of a mess because the old systems just don't work anymore. And, of course, the newspaper, the street, the subway would be talking about the pole shift. How much of our orientation and internal clock is controlled by the Earth's magnetic field is not yet known. After a pole shift, you may experience a confused, mild insomnia or nervousness. In a few days, the situation was going to calm down again anyway. The Earth's magnetic field would have found its new place. And if it wobbles for days, weeks, or even years, we people would have to endure repeated disruptions to our tech and higher solar storms and UV radiation. Don't miss a new video. Subscribe now.